Hi guys, so today we are going to solve some questions based on the chapter distribution. First question says five identical chocolates need to be distributed amongst three children. In how many ways can this be done? So there are five identical chocolates and there are three children. Now we have identical objects but the distinct groups. So groups means these three children. So obviously children can't be identical, they have to be different. This means over here we are distributing five identical chocolates to three students who are not similar looking. Also, over here, we cannot recognize which chocolate is distributed to which student. Hence, selection of object is not required over here. Because even if we select the object, we'll never get to know that which chocolate is selected. But over here, which child gets how many is important. So distribution is important over here. So the pattern of distribution could be 500, 410, 320. That is, I'll give all five chocolates to one student, and the other students will get 00. Now I'll give four to one, the other one will get one, and the girl will get 0. Then 320, 311, and 221. Now over here, the order is also important. That means 500 can further be classified as 500, 050, 005. So this is going to be the order. So there are three ways. Now 411, we'll have six ways. These are the ways that we have. 320, again six ways. 311, we'll have three ways. 211, 221, we'll have three ways again. So the total number of ways are going to be 21. That means all possible distribution is 3 plus 6 plus 6 plus 3 plus 3, that is 21 ways. Moving to the next question. Before moving to the next question, we'll look at the partition method. So partition method for finding all possible way of distribution, distributing identical object into distinct group. Now understand one thing, partition method can only be applied for distributing identical objects to distinct groups. Now, how many partitions are required to divide objects into three groups? So we require two partitions. There's a formula of partition also. So it's basically groups minus 1, and all possible ways of distribution would be objects plus partition C partition. So over here it is going to be 5 objects plus 2 partitions, that is 7 C. And how many partitions do we have? We have 2 partitions. So it is going to be 7 C2. That is 21 ways. So this is another way of solving the previous question. Let's move to the next question. 101 identical coconuts need to be distributed among 25 priests. In how many ways can this be done? Now, question 3 is 101 coconuts need to be distributed to 25 priests. In how many ways can this be done if each priest is given at least 2 coconuts? So question 2 and question 3 are interrelated. Question 3 just have one change, that is if each priest is to be given at least 2 coconuts. Let's move to question 2 now. 101 identical objects, 25 distinct groups. That means the partition is going to be groups minus 1, that is 25 minus 1, which is 24. So total ways of distribution would be 101 plus 24, C24. That is 125, C24, which is option 1. Moving to the next question, that is question 3. At least 2 coconuts to each priest. That means we have to give 2 coconuts to each priest. So out of 101, 50 coconuts would be given in minimum to 2 priests, not to 25 priests. We have to give at least 2 coconuts to each priest. How many priests are there? We have 25 priests. That means how many coconuts do we need to distribute in a minimum way? So 25 into 2, that is 50 coconuts would be distributed in a minimum manner. Out of 101, 50 coconuts are already distributed, That means now we need to distribute 51 identical objects to 24 groups. So 51 plus 24, C24 is going to be the answer. Not 24 groups, we need to distribute 25 groups. But over here, partition is equal to groups minus 1, hence 25 minus 1, which is 24, and the number of partitions would be 24. Again, by applying the same formula, we'll get the answer as 75C24, which is option 1. Moving to the next question, find the number of non-negative integral solutions to the equation a plus b plus c plus d plus e is equal to 50. Now we want non-negative integral solutions. So it's basically distribute 50 identical objects amongst 5 distinct groups. So how many partitions do we need? We need 4 partitions. The non-negative integral solutions are going to be 50 plus 4c4, that is 54c4, which is option 2. Moving to the next question, find the number of positive integral solutions to equation a plus b plus c plus d plus e is equal to 50. Now over here we need positive integral solutions. Positive integral solutions, that means also distribute 50 identical objects. But over here we need positive integral solutions, hence we don't have to consider 0. So the value of a, b, c, d, e must be either greater than or equal to 1. Let us assume it as 1. So if all the values is 1, then instead of 50, it will become 45. So now, basically, we have distributed 1 to each. And now, as we have distributed 1 to each, out of 50, 45 are left. And now we are going to distribute 45 identical objects into 5 distinct groups. So how many partitions will be required? We will require 5 minus 1, that is 4 partitions. So 45 plus 4c4, that is 49c4, which is option 2 is the answer. Moving to the next question. 5 hats to be distributed amongst 3 boxes. In how many ways can this be done? 5 hats, seventh one, 5 hats to be distributed among 3 boxes. In how many ways can this be done? If one of the boxes gets 3 hats, the other box gets 1 hat, and the remaining box also gets 1 hat. Eighth question, 5 hats to be distributed among 3 boxes. In how many ways can this be done if first box gets 2 hats, second box gets 1 hat, and the third box gets 2 hats? Now, distinct objects and distinct groups. So selection of objects is required as the objects are distinct. Which box gets how many is also important. So the pattern of distribution which we have already learned is this. Now, order is also important. So the number of ways would be this: 3 ways, 6 ways, 6 ways, 3 ways, and 3 ways. Now selection of objects is required over here. As selection is required, combination will come into the scenario. So it will be 5C5, 1 and 1. Basically, we are selecting 5 objects out of 5, 0 objects out of 5, 0 objects out of 5. Second case would be selecting 4 objects out of 5, 1 object out of the remaining 1, and so on. So after solving this, we'll get the distribution as 1, 5, 10, 20, and 30. Now we need to calculate the number of ways also. So 1 3s are 3. So it is going to be 3 ways. 5 6 are 30. So 30 ways. 10 6 are 60. So 60 ways, and so on. It's or, that means we have to add up all the values. If we add up all the values, we'll get the addition as 243. Hence option 1, 243 ways, is the answer to the 6th question. Moving to the 7th one. Now, for the 7th one, we just need to focus on the 4th distribution that we have, on the 4th pattern that we have. So it is a direct answer because it's a particular distribution. So for particular distribution, we just have to focus on the 4th one, which will give us the answer as 60. So option 1, 60 is the final answer. Moving to the next question. Now, eighth one is a type of specific distribution. So for a specific distribution, we are just going to consider the last pattern, that is 2, 1, and 2. Over here, selection of objects is required. Hence, we also have to select the object. So it is going to be 5C2. Now, 3 objects are remaining. Out of 3, we are selecting 1. So it is going to be 3C1. Now, 2 objects are remaining. Out of 2 objects, we are going to select 2. That means it is going to be 2C2. So after solving this, we'll get 30 ways. So 30 ways is the answer to the eighth question, which is option 1. Moving to the next question. Now, option approach for finding all possible ways of distributing distinct object into distinct groups. So what we'll do is, this hat has 3 options. This hat has 3 options. This hat again has 3 options. This hat again has 3 options. This hat again has 3 options. So 3 into 3 into 3 into 3 into 3, that is 3 raised to 5, which is 243. So total number of ways in such type of questions would be groups raised to objects. There were 3 groups and 5 objects, so 3 raised to 5 is the answer. Moving to the ninth question. 5 rings to be worn on 3 particular fingers of a hand. In how many ways can this be done? 10th question. 5 rings to be worn on 3 particular fingers of a hand. In how many ways can this be done if one of the fingers has 4 rings, the other finger has 1 ring, and the remaining finger has no ring? 7th. In how many ways can this be done if the first finger gets 2 rings, the second one has 1 ring, and the third one has 2 rings? Let's start with the ninth solution now. Now, distinct groups and distinct objects, 3 different looking finger, 3 different looking rings. Selection and arrangement of object is required. Which finger gets how many is also important. So this is the pattern of distribution that we have, and also order is important. We have already seen the pattern of distribution and the number of ways. So now it is going to be 5 factorial, again 5 factorial, again 5 factorial, and so on, as there are 5 rings. So 5 rings can be arranged in 5 factorial ways. Number of ways that we have are 3, 6, 6, 3, 3. So basically we are just going to multiply this. So 5 factorial into 3, 5 factorial into 6, and so on. And after adding up, we'll get the answer as 21 into 5 factorial, which is 2520 ways. So 2520 ways, which is option 2. Moving to the next question, that is the 10th one. Now 10th one is a particular distribution. So just 6 ways and 5 factorial. So 6 into 5 factorial, that is 720 ways, is the answer to the 10th one, which is option 1. Now 11th question was a specific distribution. So we just have to focus on the last part, that is 2 to 1. So that is equal to 5 factorial. So 5 factorial is 120 ways. It's a specific distribution. So 120 ways, which is option 1, is the final answer. Moving to the next question. In how many ways can 4 sweets be distributed among 3 people such that each one of them gets at least 1 sweet? Each one of them gets at least 1 sweet. Distribution, distinct objects, and arrangement not required, particular way. So ways of distribution would be 2, 1, 1, 1, 2, 1, and 1, 1, 2. This is 3 ways. Now ways of selection would be 4C2. That is, out of 4 we are selecting 2. 2C1. Out of 2 we are selecting 1, and remaining 1C1. That is 6 into 2 into 1, which is 12 ways. Now 3 into 12, that is 36. So 36 is the answer to the 12th question, which is option 1. Just focus on the things given inside the box. Thank you.